bipolar junction transistor. This is one type of transistor. Now it is a BJT is a 3-terminal device. It is a 3-terminal electronic device. Those terminals are emitter, base, collector. So first of all, I will explain the construction part. The basic construction part here. See, one type of semiconductors. Generally, semiconductors are two types: pure and impure. Impure is nothing but a extrinsic semiconductor. So that extrinsic semiconductor is again classified into two types: N type and P type. Practically used semiconductors are N type and P type semiconductor because conductivity is very high. So pure semiconductor is converted into impure semiconductor. Intrinsic semiconductor is converted into extrinsic semiconductor due to doping process. Doping process is nothing but adding impurity to the pure semiconductor. So finally, here we have to take two types of semiconductors. One is N-type semiconductor, right, and another is P-type semiconductor. So now here it requires, this transistor requires 3 terminals. So 3 terminals means here we have to take 3 semiconductors. 3 semiconductors, but available semiconductors are 2 semiconductors are there. That's why we have to take one semiconductor 2 times and another semiconductor should be 1 time. Finally, it gives the 3 semiconductors. The basic process is like this: sandwiching of one type of semiconductor, in between opposite semiconductor. That means here first of all I am taking one p-type semiconductor, sandwiches in between 2 n-type semiconductors. This is one basic process, right? And another process I am taking now, one n-type semiconductor sandwiching in between 2 p-type semiconductors. In between p-type semiconductors, opposite semiconductor. If you take here n-type, we have to perform the sandwiching operation with opposite semiconductors. Here p-type, and this is p-type, and here these two are n-types, right? And otherwise, another simple representation we can write here: one p-n junction diode adds with another semiconductor. If p-n junction diode adds with another p-type semiconductor right side, and if the p-n junction diode adds with another n-type semiconductor left side, right? So any one process we have to apply. The simple process is like this here. So finally, which has 3 semiconductors. So one semiconductor terminal, from each semiconductor we have to take one terminal is outside. From each semiconductor we have to take one terminal. So here 3 semiconductors are there. That's why I am taking now 3 terminals. So this is the basic electronic device, 3-terminal device. Those 3 terminals are emitter. One is emitter, and the middle one is always acts as base, and another is acts as collector, right? So this is emitter. Generally we have to denote with E, right? And the middle terminal is base, denoted with B, and this is collector denoted with C. So the names of the terminals are E, B, C: emitter, base, collector. So why the names are emitter, base, collector? That part we have to discuss now, right? So just now I have explained here 3 semiconductors are there. 3 semiconductors are there, right? So each semiconductor is extrinsic semiconductor. So all these 3 semiconductors are extrinsic semiconductors. Extrinsic semiconductor is nothing but after doping process, pure semiconductor becomes impure semiconductor, intrinsic becomes extrinsic. So doping process it has to perform here. So it requires compulsory doping process. So according to the doping level, these semiconductors are classified into 3 types. One is emitter, base, and collector. Emitter is highly doped semiconductor, collector is moderately doped semiconductor, and base is lightly doped semiconductor. So first of all I am writing now emitter. It is heavily doped semiconductor. It is heavily doped semiconductor. This emitter should be heavily doped semiconductor, either N-type or P-type. So 2 types are possible here. One is NP and another is PNP, right? From these 3 semiconductor, one semiconductor should be highly doped, right? So one semiconductor should be highly doped, then the doping process is very high. What happens here? Which supplies the majority carriers, large number of majority carriers. So therefore it supplies large number of carriers, large number of majority carriers. See, just now I have explained these three semiconductors are not equally doped semiconductors. Here three semiconductors are there. All these are not equally doped here. From these three, one semiconductor is highly doped semiconductor. Doping level is very high. If the doping level is very high, what happens here? Majority carrier concentration is also very high. If the majority carrier concentration is very high, this semiconductor always emits the carriers, right? So highly doped semiconductor, internally it has more number of majority carriers. It always supplies the majority carriers, always emits the majority carriers. That's why the name of this semiconductor is here emitter, right? Highly doped semiconductor terminal acts as emitter, right? So this one semiconductor is highly doped semiconductor. If the doping level is very high, majority carrier concentration is also very high. According to the diffusion process, carriers always flows from high concentration to lower concentration, higher concentration to the lower concentration. Now this is highly doped semiconductor, majority carrier concentration is very high, then automatically it emits the carriers. That's why this semiconductor terminal is called emitter. So emitter is always highly doped semiconductor, which supplies large number of carriers. So this is the function of the emitter, right? And later one more terminal is there, that is collector. See, just now I have explained one semiconductor is highly doped semiconductor, it always emits the carriers. If it emits the carriers, these carriers has to collected by some other semiconductor, that is done by collector. That's why the name is here. It collects the carriers, right? So it collects the carriers. It collects the carriers. Those carriers are majority carriers, right? Because according to the transistor function, the large current has to flow through the device. So current flow is nothing but flow of charge carriers. Now it requires more number of charge carriers flow. To flow that purpose, one semiconductor is highly doped semiconductor, then immediately this semiconductor always emits the charge carriers, and these emitted charge carriers, these carriers collected by another semiconductor, that is collector here. So that's why the name is here collector. It has to collect these carriers emitted by emitter carriers. So majority carriers, those are emitted by the emitter. So highly doped semiconductor. This is the function of the collector. According to the transistor effective transfer characteristics, it has to collect those carriers. And those carriers are your majority carriers, right? So now what is the function of the collector? It collects the majority carriers emitted by emitter. So majority carriers emitted by which terminal? Emitter. The semiconductor emitter, that is highly doped semiconductor. Now we have to discuss what is the doping level of the collector, right? So already we have assumed this is highly doped semiconductor. That's why this collector does not highly doped semiconductor. It's not equal to this level here. So according to the standard charge properties, the charge always flows from higher concentration to lower concentration. If you take this collector is highly doped semiconductor compared to this one, then it does not collect the carriers, because this emitter is highly doped is there. Carriers always flows from higher concentration to lower concentration. Compulsory the collector requires less doping level compared to the emitter. Then only the carriers flows from emitter to collector. That function possible. So this collector, here I am writing few point here. Please remember this point. If the collector is highly doped or heavily doped, it does not collect the carriers, right? This is one drawback. So that's why it is not highly doped. And another function also there. If the doping level is very high, automatically breakdown voltage decreases. So and breakdown voltage decreases. Breakdown voltage decreases. So these are the general limitations if it is highly doped. That's why collector is not highly doped semiconductor, right? And one more condition also we have to take. If it is lightly doped, what happens, right? So if the collector is lightly doped semiconductor, let us assume lightly, right? Now let us take lightly condition. So if it is lightly doped semiconductor, then what happens here? If the collector is lightly doped semiconductor, conductivity decreases. What happens here? Conductivity decreases. So what is the general function of the doping? What is the advantage of the doping? Doping increases the conductivity. If the doping level is very less, conductivity decreases, and it does not pass. It does not pass higher currents through this semiconductor, right? So if it is lightly doped semiconductor, it does not passes the higher currents through semiconductor. But according to our practical requirement, we want high current has to pass through the collector, right? And it requires breakdown voltage is very high, right? So if the collector is heavily doped semiconductor, it does not collect the carriers because carriers always flows from higher concentration to lower concentration. If it is highly doped, the carrier collection is collection of the collector carriers are not possible and breakdown voltage decreases. So we won't take highly doped semiconductor. And another part is, if you assume here if it is lightly doped semiconductor, breakdown conductivity decreases. If the doping level is very less, conductivity decreases. It does not passes the high current. This is also not a transistor action. So therefore the perfect transistor characteristics requires, because generally we have to use this transistor as amplifier, right? So for amplification purpose, emitter junction should be always reverse bias. Emitter junction is contained in reverse bias condition. In that condition, so here breakdown voltage is very less. We want breakdown voltage very high. So that's why we have to prefer the collector semiconductor should be always moderately doped. So perfect transistor characteristics requires moderately doped collector. Moderately doped collector. Right? So now finally, what is the doping level of the collector? Collector doping level is moderately, not very high and not very less. So collector is medium doping level is used here. So one semiconductor is highly doped semiconductor and another semiconductor is moderately doped, that is medium doping level, not very high and not very less. And another important point is cross-sectional area. Cross-sectional area of collector. Cross-sectional area of collector should be very high. So we have to take here moderately doping level. Doping level is moderately, but cross-sectional area of collector should be very high because it has to collect the carriers emitted by the emitter, and due to that carriers flow, so large heat will be developed here because here always collector junction is contained in reverse biased condition. So the heat, whatever the heat develops within that collector, it has to distribute to some other devices. for that purpose it requires a large cross-sectional area. So directly we can write here heat produced at collector junction rapidly transferred to surroundings, right? So this is another important point. That's why here we have to take another important condition is cross-sectional area of the collector should be more. Cross-sectional area of the collector should be more, because the collector junction is always operates in reverse biased condition. In that reverse biased condition, it develops the heat, it produces the heat. So the heat produced at collector junction is rapidly transferred to the other devices like surroundings. For that purpose, it requires large cross-sectional area. So cross-sectional area of the collector is very high and doping level is medium. And one more device is there, that is base, right? So base should be lightly doped semiconductor. It is lightly doped semiconductor because the base doping level is very less required here, because the base acts as a medium between the emitter and collector. So it acts as medium. It acts as medium between emitter and collector. So it acts as a medium between emitter and collector. Whatever the carriers emitted by the emitter has to transfer to the collector side. So for that purpose it requires some other material in between these two. That material is here base, but the doping level is here very less. If the doping level of base is very high, what happens here? The base is exactly located in middle of these two. If the doping level is very high here, more recombination process exists here. Due to that recombination process, what happens here? Less number of carriers are enters into the collector. So then it does not perform the transistor action. That's why. So if base is highly doped or heavily doped, base is heavily doped, more recombination process exists at base. Therefore less number of carriers or very few carriers enters into collectors, right? So less number of means very few carriers enters into the collector. This is not a transistor action. This is not transistor action. This is not transistor action, right? That's why always we want base should be lightly doped semiconductor. So here I have wrote one simple point here. If it is heavily doped, what are the drawbacks here? So this is comes under drawback. Recombination process exists here. Then due to that, what happens? Less number of carriers enters into the collector. So all the carriers does not enters into the collector. So automatically the collector current is decreases. So for that process, this base should be always lightly doped semiconductors, and base requires less cross-sectional area, right? Cross-sectional area is less, right? So base requires cross-sectional area is less and it should be lightly doped semiconductor. So finally here we have to remember few points here. Those points are emitter should be highly doped semiconductor, and it supplies the large number of majority carriers. That's why the name is here emitter. And another is collector. Collector is moderately doped semiconductor, and cross-sectional area of the collector is very high, and base is lightly doped semiconductor. The cross-sectional area of the base is very less. So these are the general requirements. So finally here we have discussed the emitter, base, collector, and similarly we have to discuss junctions here, because combinations of two semiconductors acts as one junction, and what is the function of each junction, and regions, different regions, all this we have to discuss now, right? So please take this now.